Second order partial derivative can be classified into two parts. One is unmixed, another is a mixed. In unmixed partial derivative, like del 2f upon del x2, del 2f upon del y2, where single variable is involved, called as unmixed or pure type second order partial derivative, and where both are involved, x and y. So del 2f with respect to x as well as with respect to y is nothing but called mixed second order partial derivative. In today's video, I am going to focus myself to teach you how to find the second order partial derivative unmixed type. Now let us take some examples. Here is the example 1, f of xy equals to x square y cube given, and we need to find second order partial derivative with respect to x, that is del 2f by del x2 equals to how much? Solution: we have f of xy equals to x square y cube, and we need to find del 2f by del x2. So step 1, first we'll find out del f by del x. It is also called as dou f by dou x, one and the same, equals to, that is differentiating partially with respect to x. So dou f by dou x or del f by del x equals to partial differentiation of x cube, x square y cube with respect to x. While doing with respect to x, y is constant, so it is taken out of operation. We need to do derivative of x square alone, so that is equals to y cube, and differentiation of x square is with respect to x is nothing but 2x. So del f by del x equals to 2x y cube. Now this is the result number 1. Now differentiating again with respect to x. So del 2f by del x2 equals to partial differentiation of 2x y cube with respect to x. So y cube again is a constant, 2 is also constant, they are taken out of operation. So 2y cube partial differentiation of x with respect to x, that is nothing but 1. So 2y cube multiplied by 1. So del 2f by del x2, that is partial differentiation of f, second order partial differentiation of f with respect to x is nothing but 2y cube. This is the result. Suppose the same problem is asked with respect to y, then how to do? So step 1, first of all we will write differentiating partially with respect to y. So del f by del y equals to partial differentiation of x square y cube with respect to y. While doing with respect to y, x becomes constant, so we need to take it out of the operation, Now partially differentiating y cube with respect to y. So x square, partial differentiation of y cube is 3y square. So del f by del y equals to 3x square y square. Differentiating again with respect to y. So del 2f by del y2 equals to partial differentiation of 3x square y square with respect to y. So that is equals to, we take x square term constant and 3 is also constant. So 3x square taken out of operation. Now partial differentiation of y square with respect to y. So this is equals to 3x square. Y square derivative is 2y. So partial differentiation of f, second order partial differentiation of f with respect to y, that is del 2f by del y2 equals to 6 x square y. This is required solution. If given function is composite function, then we need to apply chain rule of partial differentiation. For example 3, sine of xy. To find the partial derivative of this function with respect to x or either with respect to y, we need to apply chain rule. So let xy equals to u. Therefore, f of xy equals to sine u. Now, differentiating partially with respect to u. So, dou f by dou u equals to partial differentiation of sine u with respect to u equals to cos u. Call it equation number 1. After that, since u equals to xy, differentiating partially with respect to x. So, dou u by dou x equals to partial differentiation of xy with respect to x equals to y multiplied by 1. Partial derivative of x is 1 and y is constant. Therefore, dou f by dou x equals to, now applying the chain rule, that is dou f by dou u multiplied by dou u by dou x equals to cos u multiplied by u. Therefore, dou f by dou x equals to y cos u. Now replacing back the u value nothing but xy. So cos of xy. So dou f by dou x equals to y cos of xy. Call it 2. But we need to find the second order derivative with respect to x. So we need to do derivative once again. To find second order derivative with respect to x. So what you do? Differentiating again partially with respect to x. So we get dou 2f by dou x2 or del 2f by del x2 equals to partial differentiation of y cos of xy with respect to x. So y is being constant, kept as it is. Now partial differentiation of cos xy, again we need to apply chain rule. For that, first we have to find out partial derivative of cos of xy, that is minus sine of xy multiplied by partial differentiation of xy with respect to x. So this is equivalent to minus y sine of xy, and partial differentiation of xy with respect to x is y. Therefore, finally we get dou 2f by dou x2 equals to minus y square sine of xy. Whenever a function is in the composite form, we always need to apply chain rule. In this example, I am going to apply chain rule directly. In earlier example, I had applied the chain rule in 2 steps, but here I am going to apply chain rule directly. That is, from basic information, if f of xy equals to under root of x square plus y square, and if I call x square plus y square as u, I suppose x square plus y square equals to u. Therefore, f of xy is nothing but under root of u. Now, differentiating partially with respect to y, because we need to find second order derivative with respect to y. So we get here dou f by dou y equals to partial differentiation of root u with respect to y. Here I am going to apply the chain rule. The chain rule becomes 1 upon 2 root u. Again, differentiating partially u with respect to y. Therefore, dou f by dou y equals to 1 upon 2 root u, and u nothing but x square plus y square. So with respect to y, that is equals to partial differentiation of x square is 0 and partial differentiation of y square is 2y. So 2y, and replacing back the u value, u nothing but x square plus y square. So we get here dou f by dou y equals to 2y divided by 2 into x square plus y square, cancelling 2. So we get dou f by dou y equals to y divided by under root of x square plus y square. Now we have to find the second order derivative with respect to y, and the variable y is present both in numerator as well as in the denominator. So y is present both in numerator and denominator. So we need to apply the quotient rule of derivative. This is the quotient rule of derivative. You might be knowing very well this formula. So where u equals to y and v equals to under root of x square plus y square. So we will apply quotient rule to find out second order partial derivative with respect to y. So differentiating again with respect to y. So dou 2f by dou y2 equals to partial differentiation of dou f by dou y with respect to y equals to partial differentiation of y upon under root of x square plus y square with respect to y. Now putting in this formula, that is, so putting into the formula of quotient rule, so this is v, this is du by dy, then y as it is, then derivative of denominator and denominator square. On simplifying, dou 2f by dou y square, we get here x square plus y square minus y square upon under root of x square plus y square multiplied by x square plus y square. Y square get cancelled. So dou 2f by dou y square equals to x square divided by x square plus y square whole raised to 3 by 2. So this is required solution. Example 5. It is a very popular problem, very important problem, examination point of view, and this question is being asked in many other examinations. Since f of xy equals to log of x square plus y square, even it is a composite function. So x square plus y square equals to u. Then dou f by dou x equals to dou f by dou u multiplied by dou u by dou x. This is equals to 1 upon u. The derivative of log u is nothing but 1 upon u. So derivative of log u equals to 1 upon u multiplied by dou u by dou x, that is partial derivative of x square plus y square with respect to x. So this is equals to 2x divided by x square plus y square. Now we'll find out second order derivative with respect to x. Dou 2f by dou x2 equals to partial derivative of dou f by dou x with respect to x. So this is equals to partial derivative of 2x upon x square plus y square with respect to x. Here we need to apply quotient rule, that is derivative of u upon v with respect to x equals to v du by dx minus u dv by dx divided by v square. So here u equals to 2x and v equals to x square plus y square. Putting into this formula, we get dou 2f by dou x2 equals to 2y square minus 2x square divided by x square plus y square. Let us call it expression number 1. Similarly, we get dou 2f by dou y2 or del 2f by del y2 equals to 2x square plus 2y square minus 4y square divided by x square plus y square whole square. This is equivalent to minus 2y square plus 2x square divided by x square plus y square whole square. Call it equation number 2. Now adding 1 and 2. So del 2f by del x2 plus del 2f by del y2 equals to, this is the first part, this is the second part. So adding both 1 and 2, simplifying, we get 0. Therefore, del 2f by del x2 plus del 2f by del y2 equals to 0. Hence, proved. I request you to solve more and more problems from your textbook. If you find any difficulty, let me know through the comment box. And how did you find this information, these solutions? Let me know and write down your comment in the comment box. Meet you again with the next topic, next episode. Till then, wish you good luck. All the best.